Hi, Kristen Atchison here, and we are going to finish up our discussion of independent groups and within subjects designs. Both are kinds of experimental designs. This second part, we're going to be talking about within subjects or repeated measures experimental designs, and then a summary of a pros and cons between the two. So, within subjects or repeated measures designs, again, these are synonymous. And they're synonymous for a couple of reasons. So, what we're doing in these designs is we are repeatedly measuring the same group of people. Another way to say that is we're going to look at the difference between our treatment conditions within a group of subjects. So that's where they get their names. Again, different textbooks and different places are going to use different terminology. We're going to go ahead and use them both interchangeably so that you're not thrown off if you encounter this terminology elsewhere. So within subjects design, why do we use this within subjects repeated measures design? The big advantage of it is we do not need to balance individual differences across the conditions. We don't have to worry about, are these groups equal? We don't have to worry about matching them on some matching variable. Because we have the same group of people in our treatment condition that we have in our control condition. This means that our variability due to individual difference is eliminated. It's not there. It's never been there. And this will be a big deal when we talk about the calculations, is that because we've eliminated this individual difference, we're going to have to calculate statistics differently for within subjects design than we would for an independent groups design. Another big advantage is that we need fewer participants. If you need 10 data points for each condition, you need 10 people. So you can half the number of participants really, really easily just by using a within subjects design. This makes it really convenient and efficient. You can get more data out of fewer people. You can do less work then, to some extent. You can collect less subject information. It really can save you a lot of work. It also is more sensitive, and this is because and the sensitivity is to detect the effect of an independent variable when it's there. So if the independent variable is causing change, a sensitive experiment will be able to find that. It'll be able to say, yeah, it caused change. And so this is a benefit. The reason why it is more sensitive is because the variability due to individual differences has been eliminated. It's not there. It's never been there. Remember, because we don't have different groups of people, we have one group of people that we're repeatedly measuring, there is no individual difference between the groups, okay? So if you don't have to worry about differences in IQ between the groups, the IQs are going to be the same. You don't have to worry about these subject variables between the two groups because the two groups are absolutely the same. Because we've taken out that variability due to individual differences, there's less, the variability that's left is more likely to be able to be due to that independent variable. We're going to be able to see that better. It's kind of like a cloudy day, a foggy day versus a sunny day. That fog is those individual differences. And so it's harder to see something with that fog. By taking out that individual differences, by taking away that fog, it is a more sensitive experiment because we can see and detect the effect of an independent variable easier. Now, everything has got its disadvantages, and the major disadvantage of a repeated measures design is order effects. Again, we've talked about this a little bit already, and these order effects or testing effects are called order effects for within subject design. And so this testing is just by repeatedly testing somebody, we're gonna have negative consequences from that. A behavior at one point in time might be influenced by the order of the conditions and contribute to the subsequent testings, but never the first. This can be called, we can have carryover effects, which are changes that are caused by these lingering after effects of a previous condition. So if you do a study where you're altering somebody's mood, and in the first condition, you make them really, really happy, and then the second condition, you try to make them really, really grumpy, well, there probably are going to be lingering after effects, these carryover effects from that mood change from the first condition. So you may not be able to make them as grumpy. So that wouldn't be a great reason to do within subject design on a study like that because of carryover effects. We can also have progressive error, which is just that we change our behavior related to these general experiences in participating in research. So I teach research methods. I'm a developmental psychologist who focused on infant research. And when we first moved to California, my daughter was in a study at Berkeley. And in this study at Berkeley, they were looking at motor development as related to language development. So this was a correlational study, and every month they would send me measurements on her motor development and measures on her language development. Well, I had some serious progressive error issues. These changes of just repeatedly measuring her, and again, I am literally teach this stuff. I had problems recording her motor development. Some of that was just because we had moved several times in a very short period of time with a young infant. But at the end of the study, they emailed me and they're like, so when did she walk? When did she crawl? And I had to go back and look at pictures and really try and figure that out because I had progressive error. I had made effects because I just had repeatedly participated in this research. One of those examples of progressive error can be practice effects. They can go the other way too. So a practice effect, you could just get better at something. Test taking is one of those things. So the first time you take a test for any instructor, it's usually one of the harder tests because you're not sure what that instructor's tests are going to be like. And so the subsequent tests you usually improve because of practice effects. Fatigue. You could just get tired of being measured over and over and over again. You could just not be paying attention to the details as much. You might be having a hard time remembering what you've done before, or that's part of the problem. And that's what my progressive error was, is I had a hard time remembering what I had said the last time. And so did it change or did it not change? And my interpretation of what, walking was and one time was a little bit different than when she was older. And so those progressive errors are where I messed up. I'm sure my data got thrown out of that study because of those progressive errors. So that's the major disadvantage of a repeated measures design are these order effects. That somehow by repeatedly measuring something, the order of those conditions will influence the behavior of those subsequent testings. So here's an example. So say we have two studies that we're looking at, and this is just to show you how order effects can mess it up. And the problem is you don't know if you have order effects or not. So here's the first part A, says original scores with no order effect. And it's treatment 1 and treatment 2, and these are just made up hypothetical scores of a hypothetical research study. And it's all vague, and that's on purpose. The second set, B, is those modified scores with a 5-point order effect. Okay, so the first original scores, if you look at the means, there's no difference between the means, right? Okay, so 2020, if we do a statistical test, will come up, okay, there's nothing here. We fail to reject the null hypothesis, okay? Now, this second set, we've added a hypothetical 5-point order effect. Maybe doing the second treatment second, doing it second gives you those practice effects and you get better. And so you get 5 more questions right. And so then we look at those means and we have a mean that's 5 points higher than the first treatment. So now it looks like there's a difference between our two groups. It looks like our treatment mattered. But what's really going on here is order effects. And so we'll talk about how we're going to control for those. So these order effects must be balanced or averaged across the conditions. Remember, if we can't hold something constant, if we can't keep it from changing, then we need to balance it and spread it evenly across the conditions so that we're distributing these practice effects across all of the conditions. So if there is an issue with practice effects, that treatment 1 gets it and treatment 2 gets it. This doesn't eliminate those practice effects, but it averages them across the conditions of the experiment so that they're no longer contributing to major differences between the groups. We're no longer allowing that systematic variance by counterbalancing them this way. So there's different ways to counterbalance order effects. There's full counterbalancing and partial counterbalancing. We'll talk about both of these in more detail. So here's an example of what counterbalancing would look like with that same hypothetical data or similar hypothetical data. So in this hypothetical data, we have no order effect, but we do have a difference between the two groups. So mean of 20 versus a mean of 26. So we do have a difference between the groups. But if we were to just add 5 to treatment 2, that 5-point order effect to treatment 2, we'd end up with a much bigger difference that would look like, hey, this is a huge difference, right? There's a big difference between treatment 1 and treatment 2 because that order effect would trick us. But what you can do is you can counterbalance it, and you can have half of the participants get treatment 1 and then treatment 2, and so treatment 2 gets that 5-point boost from the practice effect. But you can also, again, by counterbalancing this, you can have the other half of the group get treatment 2 first and then treatment 1, and so we spread that out. So if you look here, we'll see that treatment 2 gets those 5-point order effects because it's the one that went second. It gets those practice effects. You got better, you answered 5 more questions correctly. Whereas this other order, we have treatment 1 gets those 5-point order effects, that 5-point practice effect. And we just got better, right? And so what we'll see is we'll still see that same difference in the mean. If you look at the mean difference between the original scores, we've got a mean difference of 6. If you look at the mean difference between our ones with order effects balanced, we still have a mean difference of 6. So our difference is maintained. We've balanced those order effects equally among the two groups, so it's no longer contributing to any differences we might see between the groups. We're no longer allowing it to systematically vary with the independent variable. So, full versus partial counterbalancing. Full counterbalancing is when all possible orders are offered. And that is really easy to do when you have 2 or 3 conditions. So what we just did in that example was full counterbalancing. You have the option of getting treatment 1, then treatment 2, or the other option is getting treatment 2, then treatment 1. Those are the only 2 options. And so all those possible orders have been offered. With 3, it's still possible, right? It gets a little bit more tricky. We go up. And you can do this really easily with quick measurements. Partial counterbalancing gives you just a subset of the possible orders that are offered. This is used when there are tons of levels, and offering every order is not possible. And we'll talk about partial counterbalancing and full counterbalancing a little bit more. So full counterbalancing, what's better than offering every order of conditions to different participants is offering every order of conditions to the same participant. So what we can have is something that's called complete repeated measures. So that means that not only does every participant get both conditions, every participant gets both orders. So in the example of our treatment 1 versus treatment 2, instead of having treatment 1 versus treatment 2 for one person, and for the other half of the group, we get treatment 2, then treatment 1, within each group, they would get treatment 1, then treatment 2, and then treatment 2, then treatment 1. We would have all possible orders so that we really are making sure that any differences are balanced equitably across the groups. For these complete designs, we can use block randomization again. So in 2 conditions, that would be A, B, B, A. That's what I just talked about, right? So we have condition 1, then condition 2, then condition 2, condition 1. So everything gets, and we would have the opposite. We'd have B, A, B too, right? So we have everything spread out equally around within the participant. In 3 conditions, we start to get a lot more blocks, right? So we have 6 blocks, so that gets a lot harder. Why we can't do full counterbalancing easily with more really than 4 groups is by the time you get 4 conditions, we have 24 different possible orders. 5 conditions is at 120. 6 conditions is at 720. And so this is where full counterbalancing starts to not be as possible the more options that we get, right? The more blocks that we get, the more orders that we get, the harder it is to meet that, right? 4 conditions you can probably do. 5 conditions, that's starting to get hard. You may not have 120 participants in your study. You might, but you may not. If you're doing within subject design, you might be doing it within subject design because people are hard to get. And so you're having a problem getting that many. And so 720 is definitely not an option. And so that's why we have partial counterbalancing. Partial counterbalancing allows us to still balance those order effects and balance them in an equitable way without having to use all those possible orders. So each condition, A, B, or C, must appear in each ordinal position equally often. So A has to be first the same number of times that B is first, the same number of times that C is first. C has to be last the same number of times that B is last and A is last, and all of the in-betweens. If this rule is followed, then practice effects will be balanced across all conditions and will not confound the experiment. So we've got a couple of ways we can do that. So we can select these particular orders of conditions out of those 720 to balance those practice effects. And there's 2 different ones. Now, I can teach you how to do these 2 methods, but there's a lot we're already doing in this class. So all I really want you to know is what these 2 methods are for partial counterbalancing. One of which is Latin square, and the other one is random starting order with rotation. Both of these follow the rules that we need for partial counterbalancing, is that each condition appears in the ordinal position exactly 1 time, or you can do it the same number of times, depending on how many times you want to do these, how many orders you want to get. And each participant is still randomly assigned to one of the orders. So we're still equitably balancing these order effects out, but we can do so with a subset of orders. So instead of having to do 120 orders or 700 orders, we can do a subset of that with either Latin squared or random starting order with rotation. Again, the important thing here is that each condition appears in each ordinal position, first, second, third, fourth, fifth, sixth, whatever, exactly the same number of times. And that will vary depending on how many participants you have and how many orders you have as well. So that kind of sums up our within subjects design discussion. Let's compare between versus within. So both are experimental designs. Both between subjects and within subjects designs are kinds of experiments. The difference in them is how the independent variable is manipulated. So the independent variable in a within subjects design, each participant receives each level of the independent variable. And we're going to look at the differences then within each subject. This is great because we eliminate those individual differences. That's a huge bonus. Problem is, again, we're going to have order effects. In a between subjects design, that independent variable, they only get 1 level of the independent variable. So we'll have a group for level 1, we'll have a group for level 2, and a group for level 3. So it's what we're seeing in these differences of these experimental designs is how that independent variable is manipulated for the individual subject. And we also have differences in what is being balanced or averaged across conditions to rule out these alternative explanations for findings. We saw alternative explanations again. What bell should that be ringing in your ear? That should be ringing the internal validity bell, right? Because ruling out alternative explanations is what we have to do to maintain internal validity. So for internal validity, we need to balance practice effects for within subjects designs. Again, this will be done by either a complete design, a partial counterbalancing design. We can do Latin squared, we can do random orders with rotation, whatever needs to be done, but we're balancing those order effects, those practice effects out across the conditions. With a between subjects design, to be able to maintain that internal validity, we're going to balance individual differences, okay? So we're going to randomly assign or match groups so that we're balancing those individual differences equally across the levels of the independent variable. So here's some more hypothetical data to show us the difference. So this first group of data across the top for treatment 1, treatment 2, and treatment 3 is a between subjects design. So we have 3 separate groups. We have John, Mary, Bill, and Kate in the first group. We have Sue, Tom, Dave, and Ann in the second group. And in the third group, we have Beth, Bob, Don, and Zoe. So we have a different number of subjects, right? So we have 12 subjects in this between group design, right? So we have, their scores are for group 1, we have a mean of 41 for, and then the within subjects design, sorry, I thought it was going to go the other way. The within subjects design, we have one group that's in all 3 treatment conditions. So we have John, Mary, Bill, and Kate in treatment 1, John, Mary, Bill, and Kate in treatment 2, and John, Mary, Bill, and Kate in treatment 3, okay? So in this first example, the between subjects design, the differences we have between 41, 45, and 49 could be due to our treatment, but they could also be due to individual differences. And that's our big drawback there. Whereas in our within groups design, the differences we have 41, 45, 49 could be due to our differences on our treatment effect. We know they're not due to individual differences because we don't have different people, but they could be due to order effects. And so again, what we're going to need to do in both of these is balance something. So we're getting the exact same scores in both. It's just it's going to be different as to what we're having to balance within that group. So we'll see the same scores here for treatment 2, and we'll see the same group here for treatment 2. But the problem is, again, within these differences, because we have different people in between subjects, those could be due to individual differences, where in treatment group 2 for the within subjects design, it's the same people being measured. So we know it's not the difference between John and Sue like it is in the between subjects design, because John has been measured twice, and he got a 20 in treatment 1 and he got a 25 in treatment 2. The same thing for treatment 3. The exact same scores are present in both, but they're going to mean different things, because in one group we're repeatedly measured the same people, and in the other group we have 3 different groups. So again, there's pros and cons of both designs. What you decide to do is really going to be dependent on your particular question, your particular study, who you're asking, your independent variables, your dependent variables, all of those kinds of things. So for independent groups, it requires more people. That's a drawback, right? But we have the benefic of no contamination across the variables of the independent variables. So we don't have to worry about order effects. We don't have to worry about fatigue or practice. We don't have to worry about carryover effects. None of that is going to be an issue, but they're going to require more people. For a within groups design, yay, less people. Individuals serve as their own control group, yay, less. We don't have to worry about individual differences. But we do have to worry about those order effects, that chance of experimental demand. So again, both of these studies are great studies. Both of these studies have their benefits. Both of these studies have their disadvantages. And really, which one that you or researchers choose is dependent on their particular question, their particular independent variable, their particular dependent variable. So this ends our discussion of between versus within experimental designs. Thanks.